Okay, the next question is sort of the reverse. It asks for the nature of the roots, the nature of the roots. There are really only three options. One, and it has to do with the discriminant, b squared minus 4ac. One, there are no roots. The discriminant is negative or below zero. This happens when the parabola is above the x-axis. It doesn't cross the x-axis, or below the x-axis. And when you do b squared minus 4ac, you get a negative number. And that tells you instantly not to continue, that the parabola does not have x-intercepts. Two equal roots. This is a weird way of saying we just touched the x-axis once. We should just call it, it touches x-axis once. We didn't call it two equal roots. But there's two roots with the equal value. That's x minus 3 squared. It would only touch this parabola at 3, 0, the opposite of the factors. This occurs when the parabola only touches the x-axis at the vertex. And then finally, two unique roots. The roots are different, like x minus 3. This is what roots are. Sorry, this is actually what factors are. Those are two factors, and the roots in this case are 3 and 4. 3, 0, and 4, 0. These are the roots, 3 and 4. The quadratic function always spits out the roots. That's why we're talking about roots. Whereas these would be the equivalent factors to 3 and 4. When there are two equal roots, it's because the parabola crosses the x-axis in two unique different spots, which is why he calls it two unique roots. Okay? So it's endlessly the same method, but you just have to learn to spot which is A, which is B, which is C. Which is A, which is B, which is C. So in this case, A is always the number in front of x squared. So in this case, A is 7. B is always the number in front of the x. In this case, it's a 1. And C is always the number alone, minus 1. Now be aware, you can have parabolas that only have an A. Y is equal to x squared. This is the parent function. This only has an A, 1. In this case, the B is 0 and the C is 0. There's no x value and there's no number. You can also have parabolas that have an A and a B. In this case, no C, so keep that in mind. You can also have parabolas that only have an A and a C and no B. When there's no B or C, they are assigned a 0 value. Okay. All right, so in this case, our A is 7, our B is 1, and our C is negative 1. That means if we're taking this equation and filling it out, where we see a B, we put a 1. Where we see an A, we put a 7. And where we see a C, we put a negative 1. Well, B squared is 1. You'd be tempted to say, well, this can come out negative because that's negative 4. But negative 4 times this C value of negative 1 becomes positive 4, and times 7 becomes positive 28. This means we get 1 plus 28, which is 29. This is a positive number. This tells me that I have two unique roots with different values, or two unique roots. So it doesn't want me to solve the equation, says it right there. Just the nature of the roots. So you do that over and over again. Again, in this case, the A is 3, the B is minus 4, the C is 5. The B squared minus 4 squared is 16. The minus 4 times A, which is minus 12, times 5, which is minus 60, becomes 16 minus 60, clearly a negative number. This tells me there are no roots. There are no roots. The discriminant is negative, so the parabola is above or below the x-axis. Since it's a positive leading coefficient, it's above the x-axis. That's all they want to know in the nature of the roots. So in this case, B is minus 8, A is 8, C is 2. So minus 8 squared is 64. And then instantly, minus 4 times 2, minus 8 times 8, minus 64. 64 minus 64 is 0. This tells me this x-intercept, this vertex happens on the x-axis, so it has two roots that are equal value. Here's a good example. There is no B, so we assign a value of B of 0 here. So B squared, 0 squared, 0. Minus 4 times A, which is minus 12, times 6, which is minus 72. This is a negative value. It does not touch the x-axis at all. So it's got no roots. Without graphing, determine the number of zeros for each quadratic function. The hint is in this. So when we do a b squared minus 4ac, that will tell me the number of zeros. And the number of zeros, by the way, are number of x-intercepts. So b squared, 4 squared is 4. Minus 4 times 3 times 9 is going to be a very big number, which means 4 minus 60 is negative. I don't even have to do the number, but since he wants to see the work, minus 4 times 3 is 12. 9 times 12 is 108. So 4 minus 108 is minus 104. There are no zeros. B squared in this case is minus 30. Minus 30 squared is 900. Minus 4 times 25 is minus 100 times 9. 9 minus 900. 0. There is 1 0. It's not so hard once you get it. So there's no point in me doing it over and over again. It's the same method over and over. To do this one, though, to get your ABC, it's in factored form. Now, we could cheat right away and say, well, we don't have to use this. You've accidentally told me how many zeros there are in the factored form. I can clearly see that there are 2 unique factors here. And the roots, the zeros, will be minus 5 comma 0, the opposite of the factor. And this one will be 1 over 2, or 0.5 comma 0. I can clearly see there are 2 roots. Now, if your teacher insists you use the method, you'd have to use expansion. X times 2x is 2x squared. X times minus 1 is minus 1x plus 10x, so plus 9x. And then minus 5. So you do 9 squared, which is 81. Minus 4 times minus 5 is minus 20 times 2 is, sorry, minus 4 times minus 5 is plus 20 times 2 is plus 40. And so that's 2 real zeros. But we didn't have to do that because they gave us the factors. So you have to ask your teacher, do I, really, I don't have to expand this. I can see right there, there's 2 unique roots. Determine the value of k. So we did this already several times. So clearly the k is going to be on the test a few times. And it's the same method I was doing before. So I don't know if you really need me to do it again. But it's the same thing. We know that b squared minus 4ac, when it's got two roots that are equal, is equal to 0. So let's solve for this. Well, our b squared is minus 3 squared, so it's 9. Minus 4 times 2 is minus 8 times a, which is k. Now we solve for k. 9 is equal to 8k. K is equal to 8 over 9. So that tells me what k is when it has 2 equal real roots. When it has no roots, it must be below 0. So this time we get 9 minus 8k. Below 0, we'll do it the proper way. We'll subtract 8 from both sides. Minus 8k is smaller than minus 9, so I subtract 9 from both sides. Divide by 8. We get k is equal. We've got to change the sign direction. 9 over 8. So in this case, to have no roots, k must be bigger than 9 over 8. Therefore, to have 2 different real roots, k must be smaller than 9 over 8, because 9 over 8 is the pivot point where we have 2 equal roots. So it's either the other answers are going to be smaller or negative or bigger in most cases. Sometimes there's more options. Probably in the next question, there are more options. So again, we do it the same way. 2 equal roots, well, b squared minus 4ac must equal 0. In this case, my b squared is minus 5 squared, 25. Minus 4 times 3 is minus 12k. Keep this equation in mind, right? Why reinvent the horse? We'll just reinvent the horse, reinvent the wheel. Reinventing the horse would be interesting. So if I subtract 25 from both sides, divide by negative 12, I don't have to switch the sign because it's an equal sign. So my answer is k must be 25 divided by 12, because negative divided by negative. Now, instead of doing that again, I'm going to look for the one where we have no roots. When we have no roots, it must be negative or smaller than 0. We get minus 12k is smaller than negative 25. When I divide by minus 12 this time, I must switch the sign. It becomes k is bigger than 25 over 12. And therefore, to have two non-equal real roots, when we're bigger than 0, k must be smaller than 25 over 12. This is only true when there are, in this scenario, you can get scenarios where there's multiple situations where it's between the number or outside the number. In this case, it's just a number, and on the left of the number and on the right of the number. For this quadrant, one root is 12. Determine the value of k. Yeah, so what is the other root? So they're essentially telling us one value of x is k. So there's a couple ways to do this, but the easiest way is if we know one root is 12, we know the factors x minus 2. It's going to have to multiply something to equal our item here. Our item is this, our equation. Well, the only way this can come true is if when the minus 2 multiplies the number here, we get minus 2. That means this is plus 1. But because I have a 2 here, and because I have the root here, it could be, it's going to have to be 2x plus 1. It's either that, or it's going to be 2x minus 4 and x plus 1. So this is interesting. There could be two possible values for k. In this case, it's 2x squared, correct, plus 1x minus 4x. So that would make this minus 3x. And then minus 2, which means my k is minus 3. In this case, we get 2x squared plus 2x minus 4x. So we get 2x squared minus 2x minus 4. This one can't possibly work because it creates a minus 4. Therefore, this is the only one that could work. Therefore, our k must be minus 3. Now,